What's up everybody? Welcome back to the channel. So in today's video, it's gonna be very interesting because this video is where I put all the parts together and combine them into the machine that I showed you in the previous video in the CAD model. So it's pretty much we are still in full movement control order in Malaysia, which means it's the Malaysian equivalent version of full lockdown. So right behind me right now is actually the completed machine mechanically, but I'm not gonna show you just yet. So in today's video, I'm going to show you how I assemble the entire machine, from the base frame to the x-axis, to the y-axis, to the z-axis, and to the spindle, and basically all the mechanical parts will be assembled today. While I show you how I assemble the machine, I will also share with you some of the lessons that I learned while doing the assembly, and also the mistakes that I made, and also some of the ways I used to solve the problems that I faced when assembling the machine. But without wasting any time, so let's get to it. Alright guys, so after one day of assembly, the base frame of the machine is pretty much done, as you can see. I got the handles assembled and the leveling feet. So the next thing that I'm going to assemble will be the y-axis ball screws and linear guides. So this is the 3D model. So this is the part that I'm going to work on next. Alright. Now, ideally, you want to use these standard ball screw end supports, which are made of steel, to fit into both ends of your ball screw. But as you can see, this just doesn't fit into the C-beam. So I decided to model up a custom end support that fits into the C-beam, and this is 3D printed out of PETG. So if you have a look at the 3D model, this is how it looks when it's fully assembled. So it's not going to be as tough as the steel end supports, but it should do. So guys, as I was installing these corner plates, especially this one, I noticed there is a big gap between the aluminum profile and the corner plate. See? So there's no way I can make it flush no matter what. And after doing some investigation, I found out this piece here is actually 1 mm longer compared to this. So right now I will have to shave off 1 millimeter from this piece as well as this piece, just to make sure the corner plates are flushed when they are put together. And by the way, this piece was ordered from China, which was supposed to be 600 mm, and it came in 601 mm. This piece was cut to size by myself, so this looks fine. So on this side is actually flushed. Alright, everything looks good now. After shaving off about 1.5 millimeters from the bandsaw, everything is flushed and nice. Okay. Okay guys, as I was installing these corner plates, I ran into a little bit of problem. In the 3D model, the screws are not shown in this coupler, and now when I try to put it through the hole, the screw is actually interfering with the hole. So that means I have to make this hole a little bit bigger. So right now I'm gonna have to enlarge the hole by another 1.5 millimeter in diameter. So if you can see, the coupler that I bought, the screws are actually protruding out, but the model that I downloaded in 3D, it's actually flushed, or at least it doesn't protrude out. So guys, be careful if you are designing your own CNC machines. This is something to take note of, okay? Now, to make sure that my linear guide rail is aligned to the C-beam, I'm using a 3D printed jig just to help me align the linear guide rail. The first linear rail that I'm installing will be my reference rail, where the second rail will be referenced to. Once the reference rail is installed, the jig is removed and fastened to the other side for installing the second rail. Once the linear guide blocks are in place, I proceeded to mount the X-axis mounting plate onto the linear guide blocks just to see if they can slide freely along the rails, and apparently I need to use a dial indicator to make sure both rails are quite parallel to each other. So right now you can see I'm using a dial indicator mounted to the reference rail to check for the parallelism. I kept everything to be within a tolerance of 20 microns or 0.02 mm. So as you can see, I have the linear rails mounted and calibrated with the dial indicator. So the linear blocks and linear rails on the x-axis are done, and so I put on the mounting plate for the x-axis, z-axis. But as you can see on my design, my ball screw requires the ball nut to be flipped the other way, and I tried to do that, but unfortunately when I removed the ball nut even with a holder, it didn't work quite well. So right now all the ball bearings inside the ball nut is messed up. So when I insert the ball nut into the ball screw, I'll have to be very careful by placing the balls one by one back into the ball screw. For now, I won't be installing the ball screw for the x-axis, since I still need a flat surface to work on. So what I'll do is I'll finish off all the parts and components on the z-axis, and then I'll come back to the x-axis to mount the ball screw and the ball screw holders. The ball screw assembly is now mounted on the mounting plate, and these two aluminum profiles will be used for mounting the linear guide rails for the z-axis. Okay. And the mounting plate for the spindle will sit on this. Okay guys, as I was going through the aluminum parts to check for the dimensions for the assembly, I realized that this pocket over here is a little shallow compared to the pocket that I designed in the 3D CAD model. If you look at the 3D, the depth of the pocket is supposed to be 3 millimeters deep, and when I checked the depth of this pocket over here, the actual part, it's only about 2.5 millimeters which is not deep enough. So today I'm going to put it on the CNC mill just to mill off another 0.5 millimeter, so that when I install this plate to the ball nut, it's not going to cause a 0.5 millimeter interference. Now I suspect the 0.5 millimeter difference in the depth of this pocket is actually caused by the unevenness of the bait after clamping the material down onto the bait. So as I was milling this part, I actually had to go around the entire plate to find the highest Z position to set it as the Z0 position. So probably towards the edges of the plate, the Z height on the surface is actually lower compared to the Z height in the middle of the plate. So that's why when it milled this pocket, it actually took a higher Z position as the 0 and caused this pocket to be 0.5 millimeter short of the design depth. Alright guys, after mounting the spindle mounting plate, I was just trying to put the spindle on just to have a feel and see how it fits, and I noticed the spindle is actually rocking back and forth. So it turns out the problem is caused by these screws. So I took this plate up to the CNC to mill the counterbore holes to be deeper, and right now the screws are no longer protruding out, and this plate I added a step over here. Reason is because when I try to put this plate on, this linear rail is actually slightly longer than the profile. Okay, just trying to get a focus here. Alright, so you can see there's actually this linear rail is protruding further than the aluminum profile here, and that was causing this plate to be unable to sit flush on the aluminum profile. So right now this step here gives enough clearance for the plate to escape the protruding linear rail. So guys, if you're buying linear rails from China, so these are the things that you have to deal with if you're unlucky. Alright, so after milling the counterbore holes, now the screws looks nice and flush on the surface. So this is the spindle mounting plate, and you can see if I put the spindle on the mounting plate, it sits very flat on the plate now. It doesn't rock around anymore, so this is good. It's nice and flat. The Z-axis ball screw seems to be spinning quite smoothly as well, no issues here, so this is good. I've also completed the ball screw assembly for the X-axis. So these are the two connecting plates that connects the ball screw nut holder to the entire Z-axis. Alright. Now notice that I'm not sure if you can see clearly. I reused the spacers that comes with the bearing blocks on both sides just to get the correct spacing. So the next step for me right now is to mount the entire X-axis and Z-axis assembly to the riser plates, but there is a small problem here. It means I'll have to hold the entire subassembly here in place while trying to secure it to these two riser plates. So what I can do is I can drill 2 more holes here, put a stopper, so this entire subassembly can rest on these 2 riser plates while I'm screwing in the fasteners here. So right now I'm working on my Dutch shoe assembly, and this is the Dutch shoe holding arm. So just want to show you guys how does all these parts, little parts, work. Okay, so as you can see, there's a spring here which I use for the latch, the auto latch system. So this spring, you can take any unused pen, old pen, and recycle the spring and just cut it into half. Okay, so this is about the length you need. Okay. Alright, okay. So there's one M3 press nut and another M4 nut pressed into this recess here. Okay, so I just put this latch in place and fasten it with an M3 screw. Perfect. So I just repeat the same thing on the other side. So I got now both the left and the right arm. So and here is the Dutch shoe. Okay. So this Dutch shoe will be held in place by a magnet, which you can see over here. See? So the left arm and the right arm can slide up and down along the rail. So I can adjust the height of the Dutch shoe easily. And once I'm happy with the height, I can just lock it in place with M4 screw here. So there's a hole with a press nut inside. Okay. So this is easily adjustable. So as I was trying to finish up the mechanical assembly of this machine, I noticed there's a small problem right here. This part right here is interfering with the connector, so it just wouldn't fit right in. Alright, and because of that, I have slightly modified the design to have a cutout here. And this part was also quite flexible, so I've added some ribs in the newly printed 3D part just to stiffen it up a little bit more. This newly 3D printed part will also allow me to mount this part, this coolant hose, onto here. So that's another modification I did to this part. This is absolutely hilarious. So I totally did not expect this to happen. So you can see this coolant hose is actually shaking like crazy. Because I think this part here is too long. It's hanging down too long, and because the hose is long as well, so it's causing a lot of unnecessary vibrations. What I'll try to do is I'll try to remodel this 3D printed part and try to bring this manifold as close to these two fastening screws as possible to reduce the vibrations. I just swapped in the newly 3D printed part, and let's have a test to see how it works. This is a lot better than the previous part, so I guess this one is soft. There you have it, guys. The machine is now fully assembled mechanically, and I'm pretty happy with how all the parts fit in so far. And in the next episode, I'll be starting to work on the electronics and the electrical panel, so stay tuned for that. In case you missed the first part where I talk about the design overview and also how I prepared the parts for the 3D printed parts and machine parts, you can click on the link and it will bring you back to the first part of this series. Leave some comments down below if you guys would like me to share all the links for the parts that I purchased from various sites like Banggood, Bulkman 3D, Shopee, and etc. If you find that this video is helpful for you and give you some ideas for your next CNC build, remember to click like and smash the subscribe button, and I will see you in the next episode. Peace.